Hi guys, welcome to my channel Tech Build with Sen. Today we will be looking at another framework, which is the JVM framework, Micronaut. Please subscribe to my channel for new videos, and for more updates please click on the notification icon. Let's get started. Why Micronaut? Why we need another JVM framework? So there are lots of difference and advantage of this new framework compared to the traditional old JVM frameworks that are out there. So Micronaut framework is an open source JVM based framework that is basically built for lightweight modular applications and microservices. If you are developing an application, large enterprise application, you have to go with the microservices architecture these days due to cloud providers and lots of benefits of microservices. And if you are into a JVM applications, you will come across Micronaut and Quarkus. There is a difference between Micronaut and Quarkus, but today we will be discussing about why Micronaut framework. So what is the difference between Micronaut and other frameworks? Here I'm not comparing Micronaut with other frameworks like Quarkus, because Micronaut and Quarkus are native support for cloud applications. So they behave similarly and work similarly, but there are some different techniques for Micronaut and Quarkus. Here I'm comparing Micronaut with Spring and other frameworks, because Spring uses a reflection method for its compilation. So this differences is basically to the old traditional application, not with the latest like Quarkus or Vertex. They all does the similar kind of things but different techniques. So this comparison is with old traditional application. So what makes difference Micronaut with the other frameworks? Micronaut analyzes metadata as in the compilation time. So during the runtime, there is no metadata analysis. So Micronaut does everything in the compilation. So when you compile a Micronaut application, you might feel it takes little longer than compare with Spring application or any other traditional application, because Micronaut analyzes everything, the class and all metadata, and it creates its own metadata. Since Micronaut does everything on the compilation time, so it generates additional set of classes that represent the state of application already pre-configured. Now this enables dependency injection such as DI and expect-oriented programming, which is AOP, which must be applied efficiently when you run the application, because all the information that the application needs, it is done in the compilation time compares to the runtime. So when you run an application, it already has all the informations that the application needs, and your build time is little bit longer, but however your run time is very fast. Now let's dive into the history. Micronaut was introduced in 2018 by the creator of Grails framework, which provide native support for service discovery, distributed configuration, client-side load balancing, and authentication. The framework is licensed under Apache License v2, and it is maintained by Object Computing and the creator of Grails. The founder of Micronaut is Graham Rose, which you might already know if you are in JVM applications. He is also a founder of Grails framework. So whatever the mistake he has done on Grails framework and Spring framework, he has analyzed all those mistakes and try to not repeat on this framework. So now let's see how does Micronaut work. Micronaut uses annotation-based programming model. Since Java already have annotations-based classes, so it uses same annotation-based model. Micronaut does not use Java reflection APIs. Instead, it integrates directly with Java compiler through annotation processors. This allows Micronaut to compute an additional set of class that sit alongside user-defined class. So what does this mean? When you create a large enterprise application, you might have lots of classes in your application. So during the build time, Micronaut analyzes your class, and based on your class, it creates a metadata and create additional set of class into the application. This does not increase the application size. Why it does? Because it needs an information during the runtime. So now, why is it like that? Because other traditional applications, they use the reflection APIs. If we are using an reflection APIs, the application needs information during the runtime. So Spring frameworks, it uses reflection APIs. So during the runtime, it gets all the informations from the Java reflection APIs. But with Micronaut, it does not have a reflection API, so it does need a bunch of informations when you run the application. So during the compilation time, it generates all the metadata and is stored into the application, and during the runtime, it uses that metadata to run the application. So the classes serve to perform dependency injection as well as define compilation time, and expect-oriented proxies is completely proxies in a complete reflection manner. So what should developers know about Micronaut? So if you want to know about Micronaut and want to use a Micronaut in your Nest application, what should you know? You should know that low memory for microservice is the main thing, and fast startup time. Does Micronaut provide. So it avoids runtime reflection, dynamic class loading, runtime byte generation, and proxy generation. So Micronaut provide bunch of components. This is some of the list. Is provide out-of-the-box dependency injection, IOC, it uses aspect-oriented programming, configuration and configuration sharing, service discovery, HTTP routing, and client-side load balancing. Now let's see a little bit about the reflection. What is our reflection? Suppose you have this class. In my case, I have a record, but you can have also any class with some private properties and public methods. You might have many methods and many private or public properties. So this is a small class but in your application, it might have lots of classes with lots of methods and lots of variables. Now, if you are using a reflection on this is just one example. So during the compilation and during the build time, if we are using a reflection, the reflection will provide all the informations about methods such as this one and this one, and if you are using a private properties such as in my case I have just one, this one, and the annotation process if the class is using this one, and again they need to provide an informations about the class itself and whatever it's implementing on this class. So just imagine for just one class you need to provide over here 1, 2, 3, 4, 5 informations as well as the class metadata as well of this one. So it has a 6 items over here to provide the informations. Now, reflections is really costly when you are thinking about cloud providers, because if you are generating lambdas in AWS, cloud functions in Azure, GCP, the application needs to be a small size and really fast. But with reflections, it needs to give an informations at the runtime, and it stores all the informations in a soft cache. So the soft cache goes disables when your JVMs goes down. But when you are running in applications, the JVM doesn't goes away, because these reflections all uses the garbage collections techniques. Now, for just one class, you need to provide a bunch of informations in soft cache. Now, you are using a Spring or any other traditional framework which uses the reflections, you might have lots of class. So Spring frameworks will store all its reflections informations in a soft cache. Now, you might use Hibernate, JPA, and other libraries which uses the reflection techniques. They also will store all the information in soft cache. And your framework and other libraries does not share your cache memory. So when you are using a reflection, the cache memory goes very high and the application size goes very high in very small amount of times. So your code base is larger. For small hello world application, this might be a little bit less, but with a code base with large enterprise applications, this will cost you very much. So avoiding a reflection and soft cache memory, we can significantly decrease the application size. Since we can see in Micronaut applications, because it does not use our reflections and proxies and dynamic class loading in the runtime, so all the information is not stored anywhere on your cache. So it does everything in the build time. That's why there is no cache memory included in Micronaut, and the application size is very less in Micronaut compared to other traditional framework. So let's go to the another question. Why is Micronaut so well suited for microservices? Because traditional applications are all microservice architectures. You create a small set of service and deploy it to the cloud. Now, Micronaut is created with a mindset of microservice architecture. It is very lightweight and starts very fast. So, in context of serverless functions, message-driven microservices, or reactive streams, this all provide a bunch of applications. So it does support reactive streams with NoSQL MongoDB, or you are using PostgreSQL or RDMS. If you are using RabbitMQ, JMS, Nats, Kafka for message-driven microservices, it also does provide. Serverless applications such as AWS Lambdas, Azure functions, GCP functions, Oracle functions are supported out of the box. Now, there is another advantage of Micronaut. This is a very well supported framework with GraalVM. If you don't know about GraalVM, I will create another video on GraalVM. GraalVM is another framework from the Oracle Labs. It's another virtual machine that does AOT time compilations. It's ahead of time compilations. So Micronaut already has, Micronaut does not provide any reflections and all bytecode generation at the runtime. So this is match in the heaven. So GraalVM is bi-directionally supported with Micronaut. I will create another video on GraalVM and Micronaut later, but today we are just discussing about the Micronaut. So languages. Micronaut supports all JVM languages like Java, Kotlin, and Scala is coming soon. And Micronaut framework is itself written in Java. If you go to their Git repository, you can find all the frameworks codes are written in Java. So Kotlin is also supported and Scala is coming soon. Create application. In Micronaut, we can create applications in many different ways. You can use VS Code, IntelliJ, command line, or you can use their web UI interface. Let's see first Visual Studio Code. For the Visual Studio Code, you need to install an extension, something known as Micronaut. GraalVM tool for Micronaut. I have already installed this one. So this is a tool supported for GraalVM and Micronaut. So when you install this tool, it does not install any GraalVM for you. You need to install a GraalVM by yourself. So since I have already installed a GraalVM on my machine, which is GraalVM CE 22.1.0, which is Java 17. So to create an application on VS Code, you can type our Micronaut create application, or you can launch their tool, something like this, and create an Micronaut applications. So it will ask you the latest versions. I have the latest version 3.5.2 on my machine, which I have installed. So you can select this one. And in Micronaut, it's not just only for microservices. You can create different kind of applications such as CLI, serverless, gRPC, and message applications. So today we are creating Micronaut application, and I am using GraalVM with Java 17. Just give an application name. I will type Micronaut application demo. Then you can provide a base package for this one, Micronaut.demo. You can use different language, Groovy, Kotlin, or Java. I'm using Java. And you can select all the features. Suppose you are using security, JW2, you can select this one. Or if you are using database, it supports MySQL, R2DBC, has2 in-memory database, MicroStreams, Postgres, or if you want to use MongoDB, it has supports for MongoDB data. All the supports are there. So today I'm not including any features over there, but you can select whatever features you want, like Swagger. You can also add Swagger UI. Just select anything. It does have bunch of features available over here. So it has two built-in support for Gradle and Maven. So I will be using Gradle. It's up to you, whichever preferred build tools you are comfortable with. And it does have Kotlin test, Spock, and JUnit. So I'm using JUnit, and it will ask you where you want to save this application. Just over here, I will create this one. So it's open the applications over here, and you can see it's an traditional Java applications with source, main Java applications, and a default message, something called void main static, and it runs from here, Micronaut.run applications class. That's this one. This is the basic structure of any Java applications, which is same as the Micronaut applications. And it has some configurations YAML file over here, so you can check. And a Gradle build, which is over here, which I'm using a Micronaut. It has annotation process and bunch of the dependencies. And I'm using Java 17, so it shows Java 17 versions, and runtime is Netty. Now Micronaut, when you create an application, It's very easy to switch between an application and serverless application. It's very easy. It's like you're creating an same applications, but you can directly deploy it to serverless applications, and the traditional application don't need to change anything apart from runtime. So when you are creating a serverless application, you only need to change over here cloud providers. Either you are using AWS or GCP or Oracle clouds. The only things it will change is the runtime. There is no other changes in any of the codes or any of the things. Just the single changes over here. This is very cool feature in Micronaut. So let's see if you are creating a serverless application. Now this time I will not use VS Code. I will use their UI. So if you IO, you will find a bunch of informations all about them. So I will just use their launcher over here. So it's the same thing. You can provide all the informations, but this is just an UI, so it gives you more visibility. So here we are creating same thing over here, but this time we are creating a function application for serverless. So we're using 3.5.2 Java 17. Give a demo, something Micronaut demo, and give a base package. Now you can see a preview feature over here. So if we check the preview feature over here, it's the same kind of applications with Java classes, all same kind of things with test as JUnit. And let's see the build.gradle. Now just I explained the runtime. So this one, see, only the difference is over here is runtime lambda_java. Over here, if I go to VS Code, it has a netty. This is a traditional application, and this is a serverless application, which is lambda_java. So the only difference is runtime. There is no difference anywhere if you create these applications. So this is the basic structure of this application. Now let's add some feature. So this is an serverless application, so I can use any cloud provider. So just I will select a function over here. Micronaut has lots of building support for serverless like AWS Lambdas, AWS Lambda custom runtime, Azure function, GCP function, and Oracle function. Let's select Google Cloud function. So I'm just selecting this one, and we will check again the preview feature. So if you go to the build.gradle, so now we have these two dependencies has been added over here. So this is cloud functions GCP, and this dependency over here. Now you can create an application over here as well. Push to GitHub, download a zip or command. So as I already mentioned, in Micronaut you can create an application from command, VS Code, IntelliJ, and a UI. So on this UI you can either go download a zip or you can use a command. But if you are using a command, suppose let's see over here. So if you want to check which versions are you on Micronaut, just type MN over here. So it will give you a version. So I am with Micronaut 3.5.2. Now you can also create an application from here. So suppose if you just type create mn. Now if you want to go inside mn command, so just you need to type mn. So I am inside an Micronaut CLI. So let's create an application. So it will give you a bunch of options if you press the tab. So you can just create here, create function applications or gRPC applications or message app, I will just select here create app. So press the create app. Then if you want to add a feature, so it will give you feature. Suppose I am adding JWT, and it will ask you a Java version, so I'm selecting here 17, all kind of things. But if you are a CLI kind of persons, this is perfect. But you don't remember a lot of things on the CLI, you can still use the helper function of this one. But let's see over here, you can also select a command over here, but if you don't know what it's been generated on the command, you can use this one. And if you want to add a different and visualize these things, so this thing is visualizations is very good on this one. Suppose I want to select JWT, it gives you in security JWT. If you go and command on here feature, you can see Google Cloud and security JWT.Micronaut. So you can either just copy this one and paste it over here on the terminal, whichever terminal you are using. I'm just gonna exit from here and it will create and something like this. Now if you create like this, it will also create an application same as I did in VS Code, but this is another options. So just you can press this one, and if you press enter, the application has been created on this location. So if I go to that location for the VS Code and the command line, I think on the command line I gave an application name as Micronaut demo. That's why it's coming like this one, but in command line I gave a Micronaut applications demo. So these are the two options. Now you have another options with IntelliJ. So if you open the IntelliJ, you can create an application from here as well. So if you go to here, new project, and you have an option of Micronaut. Now while creating an application from here, it uses the same things that are being used over here. So basically from the backend side, it's calling this API or anything that SDKs they are providing, how that IntelliJ has integrated. But this is basic integration of whatever is over here. So you can either use this one as well. So here also you can give Micronaut demo. You can select allocations, create a Git repository, whatever language. You can select a language. I will select build system as Gradle, JUnit as a test framework. Just give here a base package, Micronaut.demo. I'll change this one with IntelliJ. So it's inside this folder, so it makes it easy. So base project, artifact, whatever you want. If you want to change the Java version, you can go here and click. So over here also you can select a feature. Suppose you want to add a data, Micronaut data, JDBC or JPA, whatever you want to select. Amazon DynamoDB has to in memory, or Swagger if you want to select. Open API support, Swagger UI. So you can select these things. So if you now just press create, it will create an applications on that location and it will open on your IntelliJ. So let's see over here build.gradle for this one. So it adds bunch of dependencies based on the feature you have selected over there. So I have Micronaut data, JDBC, and Swagger and API supports, and has to memory for this one. Now with IntelliJ we have added a Swagger feature. Let's see, when you add a Swagger feature, it does create an open API properties file. So these are the settings for enabling the Swagger UI. And if you see, this is just a demo controller, and if you can see on this application we have a Swagger annotation over here. but we did not added a Swagger support with VS Code. So over here we don't have any annotation. So there are some pre-configured things comes based on the annotations and features that you select over there. So when you run this application, if I run these applications, see, it's pretty fast. But you might think this is just a simple application. It doesn't have anything. So it does run 736 milliseconds. And if I check whatever it has generated, so over here, if you see build, so these are some of the meta info that Micronaut generates for the build time. As we already spoke, it does not include a reflection. So during the compilation times, it generates a bunch of class for you, which you can be found over here, annotations process. You can check all these things what has been generated. But it does generate a lot of things based on your classes and all the information that it needs in the runtime. So I just disable this one and stop this one and rerun it again. So if you can see, it starts in 505 milliseconds. So Micronaut itself is pretty fast, but as we spoke previously, Micronaut and GraalVM is a match in heaven. So if we introduce a GraalVM to this one, this will go more or less. This will be something 33 or 23 or 27. But this is just a simple application, you might be thinking. But if you are developing in some enterprise level application, this goes pretty less on that application as well. So this is very good when you are considering serverless applications as well as Kubernetes, Dockers, all kind of things. So see, this gets decreased every time. So sometimes it goes up, sometimes it goes down. Let's run from the CLI. So let's see. I have created an application with VS Code, which is this one. So let's go inside this first. So over here, let's check what is over here. Now if we do this Gradle build, this one, let's see. Now let's run the application. So to run the applications, you do Gradle run. You can see. So it's starting at 264 milliseconds. Let's stop again. Let's run again. 258. Let's run again. 258. It's almost same. So it's pretty fast. For the memory consumption, I will show you how much memory does it consumes when we generate a native image with GraalVM. Because I'm using a Mac, on this one it doesn't include a native image. So I'm showing you a memory consumption. I need to run bunch of commands, which I will not do on this video. But when we will do GraalVM integration with Micronaut, I will show you a memory consumption as well. So memory consumption is also very less on this one. Now let's see about hot reloading. Now, Micronaut does support hot reloading pretty out of the box. So let's see how we can do a hot reload. So we have a project in IntelliJ Open. So it's just a function that returns some string. Now we will see the hot reloading on this simple application, but you can do on pretty large application as well. It does work pretty well. So if I change something over here and try to access this URL, all should able to get you the data without running the application. So if you check this one, I will run this application with Gradle build. And see, the project location is project sample Micronaut IntelliJ demo. So on my terminal, I am in the same project location. If I go back over here and if I see ls, I can see IntelliJ demo of Micronaut over here. So I will just use this one. I will change anything from IntelliJ, and this build will reflect all the changes without running the applications. So I am over here. So to do the hot reloading, we have to run. This is a simple run, Gradle run. It will just run. It does not do any hot reloading. But if you want to do a hot reloading, you have to run an extra command, which is -t for continuous building. So if we do something like this, so over here you can see I have a project location over here. So if I go over here, it doesn't give you anything because the URL didn't match. So I just copy this URL, which has a get function with /, so I didn't need to pass anything, but I need to pass a path of the controller. So if I go over here and / this ones, which calls the get method and gives you an example sample. So I am over in IntelliJ, just to show you over here. So I will be here. Let's bring my terminal, which is over here. So over here. So if I change something, example, something over here like hello send. If I save this one, if you check this getting started builds, it auto reflects, and I'm not restarting anywhere anything. So if I refresh this one, it gives me hello send. Now go back again, revert this change. I'm just reverted this change. Let me show you the terminal as well. So over here, save, it does a reflection. So if I go back over here, refresh this page, example response. So I am not using any other things. The project location, if you check the same, this one, and if you check the project location of this one, as the same, that is this one. So let's do a couple of times this one. So I'm running this one in continuous mode. So I will change over here, testing the hot reload response, save it, it does something, build. If I go to the browser, refresh this one, see, testing the hot reload response. Come back over here again, hot reload is pretty good. Just save this one, it does the reflection. See, hot reload is pretty good. Again, hello hot reload. This time let's see on the terminal, it does, see, hot reload, hello hot reload, this works. But this is hot reloads, it works pretty good on this one. Let's do testing, how you will do a testing. For integration testing on Micronaut is very good. So let's stop this one this time. Let's go back to the IntelliJ. So let's change this one to, okay, let's test this one. So Micronaut, because I have selected JUnit 5 test framework to do the testing. So you can see over here that run on JUnit 5. So if you go to the test folder, traditional Java applications with test applications, so by default application. So when you run this test, let's run this test, it's nothing, just testing that application is running or not. See, embedded applications. Now when you do the integration testing, it does provide an embedded server for you out of the box, so you don't need to do any mocking or anything on Micronaut. This is also a pretty good feature on this one. So when you are testing on the controller, so you don't need to mock anything for the controller. Micronaut supports integration testing pretty good. And again, if you have test containers, if you want to use test containers, this is also pretty much supported, very well supported in Micronaut. But if you are using an enterprise applications, you will definitely use test containers. But for now we are not using a test container. This is a simple test we will run. So now let's add. So suppose we want to test this controller which is returning hello or hello hot reload. So let's test this controller. How do you test? This is integration testing. This is no unit testing. It's Micronaut supports integration testing out of the box. So I have IntelliJ auto code completion. So just I will select this one. Should return hello hot reload text from the controller, right? So I am doing this one. So you need to include a HTTP client for this one. So HTTP client is also, so you need to inject a HTTP client. So just do an inject over here, HTTP client you can do, and you need to import this one. So you need to import this one from Micronaut, not from the Java. So you have included this one from the Micronaut. Now you need to include one client which they have. So add client annotations from Micronaut, and you need to provide an URL for this one, for the controller. So in my controller I have this URL. So this URL will be over here. Let's format this code. So over here you want to call that one, right? So you can create an HTTP request from Micronaut. You can do request equal to HTTP request or get method. You have get over there. We'll do a get request. So just select get over here, and you can provide an URL. In our case we don't have anything on the URL. So if you check here again, this is a get request with a slash. So we are doing just a slash. Now we want to capture a string response equal to, let's copy this one, HTTP client dot to blocking, because in test we need to block or retrieve and the URL that we have to pass. So this one. So I will do an assertion. We will check against this one, comma, what is the text? Let's copy this text. So we'll see this one. So test it work, to test pass, it's gotten response. So this is pretty good. Like you don't need to mock anything for the controller. It keeps you out of the box. Integration supports pretty good. And for the complex scenarios, like if you want to test database, there is also no mocking on this one. You can use a test containers, Docker included over there, and in Micronaut I think 3.6 they are doing test containers built-in support in Micronaut framework itself, which is also a pretty good. So this is just a simple test. Now if I change this one to AAA hot reload, and if I run this one, it should fail. So we can see that this has got failed. It was expecting, but hello, and this one was there. So if I change this one back to whatever it was, now if we run again, I'd be saying you have to do. Now if you want to see really I am mocking or not this ones, that this thus creates an embedded server for you or not, let's see how you can verify that one. Now let's see that this is really sending a request on this controller. So if I just come over here, I'll do over here breakpoint, and if I debug I will debug this test. So you can see the debugger does comes over here. Now let's trace this one. If you want to trace, so for tracing, I will remove this debugger. So inside the resources, you have one logback.xml. On this logback.xml, you can add one property for tracing the HTTP calls and in the trace label. So if I just add this one, and if I just run this one again, so you can see it does sending and request and all those things by these clients. So you can see it sends and requests, get requests to this controller, which is our controller, because we are using a test, because it's gonna generate a random URL, random port on the test. So it's 55853, and it got a 200 response from that URL, and what they receive, it receives an hello hot reloads. That's why it tests pass. So integration testings is also and very pretty much supported on this one. So Micronaut framework is very well for developing an applications on server side as well as serverless applications, and very well supported for GraalVM. So if you are into an enterprise applications and you want and serverless applications deploy to AWS, Google Cloud, Oracle functions, or Azure functions, you definitely need a GraalVM, because that keeps our memory consumptions pretty low as well as very much startup time. Now these days, GraalVM is now being compared with like Go. Even they are in some of the benchmarks. GraalVM does pretty good with Go. With GraalVM integration, you can write an applications in embedded and any other applications as well. That gives the same benchmark as Rust, which is not a new programming language for an hardware level, or you are doing some server side also it does supports. But the benchmark with GraalVM and Rust and Go are almost same. In some of the case, Go in the GraalVM is for giving a benchmark better than Go, but it's still not as much fast as Rust. But it's because Rust and Go, they use native compilations. Even GraalVM uses the native compilations of libc. So GraalVM is going pretty good in their research and R&D development, but it will come really good in the future as well. But consider using GraalVM for enterprise level application. And thank you for your time. This was all that we have on Micronaut. So read more documentation on their official sites and know you should consider GraalVM or not on your application when you're developing on serverless applications deployed to AWS, Azure, Oracle Cloud, or anything. Please hit subscribe to my channel, so I will create more content on Tecton, CI/CD pipeline for Kubernetes. I will do lots of Angular applications in the front and Micronaut in the back with MongoDB. I will be the next one, because I need to demo GraalVM to show you an enterprise level applications with pretty fast startup time and low memory consumption. So on Micronaut with GraalVM, I will do with integration with MongoDB, which lots of classes and lots of properties and lots of methods, and you can see true benefits of not using any reflections, dynamic class loading, all those things. Please hit the subscribe buttons for the new updates. Thank you.